Hello GCC, we're back and we're ready to finish up talking about covalent compounds. So I'm ready to give you some true-false questions regarding the compound H2S. So think about the elements H and S and what kind of elements they are. All right, number one, electrons are shared in H2S. Are they shared, or do we have a metal transferring electrons to a nonmetal? So electrons are shared, true or false? That's true, right? Yeah, that's true. Number two, the bond between H and S is ionic. Ionic bond between H and S, true or false? Yeah, that's false, right? H2S is a covalent compound with a covalent bond. It's a non-metal type compound. We don't have a metal. It's not ionic. Number three, the HS bond length is less than the sum of the two radii. So again, here's the two radii, and when we bond, we overlap like that. So is the bond length less than the sum of the two atomic radii? Yes, it is. That's true. Number three is true. Number four, breaking the HS bond will release energy. Breaking the bond. So think about breaking a bond. When we break a bond, do we release energy or put energy into something? Yeah, we put energy into the bond. So that's false. That was false. So true, false, true, false. Good job. All right, moving on to the main topic of this chapter, Lewis dot structures. We're actually going to start with atoms, then we'll move to molecules. So for atoms, you simply put dots around the atom for the number of valence electrons that the atom has. Pretend the atom is like in a square. Put one dot on each side of the square before you double up and put two dots per side. So let's look at Lewis dots for the atoms of Ko, Si, Mg, and I. K, potassium. How many valence electrons? Column 1. Valence electrons. Okay, column 1 is 1. 1 valence electron. So it gets one dot. You can put it on any side you want. Up, down, left, or right. Doesn't matter. Oxygen. How many valence electrons for oxygen? It's in column 6. So 6, right? Remember, valence electrons is your column. So 6. Now for oxygen, we're going to put one dot on each side before we double up and have 6 dots. Silicon, it's under carbon. 4th column. Column 4 means 4 valence electrons. Yeah, 4 valence electrons. So for Si, there's 1 per side, and it has to look like that. That's your only option. Mg. Mg's in column 2. So 2 dots, 1 on each side. You can have a top to right, top, bottom, left, right, just so you have 2 dots on different sides. Finally, iodine. Iodine is in column 7. So how many valence electrons? 7. So again, we have I. We're going to have 1 on each side before we double up. So it's going to look like this when you put it all together. There's your K with 1 valence electron, O with 6, silicon with 4, magnesium with 2, and iodine with 7. All right, so Lewis dot structures of atoms are okay, but molecules are way more important. So here's the steps to doing a Lewis dot structure for a molecule. And these are only for covalent molecules, by the way. First of all, number 1, always add up the total number of valence electrons in the compound. Number 2, surround the central atom with all the other atoms and start out with single bonds to them. The central atom is underlined, by the way, or in bold, so you'll know which one the center atom is. Number 3, we want all the atoms to be happy. Atoms want to have 8 electrons around them, Except hydrogen, again, wants to be like helium, which only has 2. So all of our nonmetal atoms are going to have 8 electrons around them in the Lewis dot structure, except for hydrogen, which needs 2. So do that. Make everybody happy. Number 4, make sure the number of dots, which represent electrons, in your drawing, your Lewis dot structure, is the same that you added up in step 1. So bonding electrons are shared. We represent that with a line. A line between 2 atoms is a single bond and represents 2 electrons in that line. If you have 2 lines between 2 atoms, that represents a double bond, which means 4 electrons in the bond. And if you have 3 lines between 2 atoms, that represents 6 electrons in the bond. Now, lone pairs are unshared electrons. They're not between 2 atoms. They belong to 1 atom only, and they are shown as dots, and they're always in pairs. Thus, we call them lone pairs. Now, here's a hint. If you try single bonds and that doesn't work, then you need to start doubling. 1 double bond at a time. Don't double everything, just 1 double bond. See if that works. If double bonds don't work, try triple bonds. Okay, so let's look at a couple of examples, and then I'm going to send you to some videos where I'm working out by hand some Lewis dot structures. You need to watch those videos. Okay, first example is H2O. Add up the valence electrons. Hydrogen is in the first column, so it has 1 valence electron. There are 2 hydrogens, so 2 times 1, plus O, oxygen, is in column 6, 6 valence electrons, and there's only 1 O. So it's 2 times 1 plus 6 is 8, so our picture will have 8 electrons in it. Now the center atom can never be a hydrogen because it can only have 2 electrons around it, which is basically a single bond. So it can't be in the center. So oxygen has to be in the center. I really didn't need to underline oxygen because hydrogen is never in the center. So it had to be oxygen. So let's put oxygen in the center and draw a line to a hydrogen atom out to the side and a line to a hydrogen atom below it. So we have single bonds. So now let's look at our structure. The hydrogen atoms already have 2 electrons because of the bond to them. The bond counts for both atoms, so hydrogen has 2 electrons in that bond. So it's done. The other hydrogen also has a bond, so it has 2 electrons, so it's done. Hydrogens need 2 electrons in the drawing to be happy, so the hydrogens are good. Now oxygen needs to have 8 electrons around it in the drawing. Right now it has 2 bonds towards it. So 1, 2, 3, 4. So it needs 4 more electrons. And those are going to be lone pairs. And there's the drawing. It looks like that. We draw 4 dots, 2 pairs around the O. So let's look at my cursor in the picture. See, this hydrogen has the 1 bond around it, which is 2 electrons in that bond. So hydrogen has 2, which is good. The other hydrogen is the same. It has a bond, so it's good. Now look at around the O. It includes both bonds and the 4 dots. How many electrons is that? Well, 2 in the bond, 2 in the other bond makes 4, plus 5, 6, 7, 8. So it has 8. So oxygen is happy because it has to have 8. Remember, in the drawing, you need to have 8 electrons around you. Hydrogen only needs 2 to be happy. Now, check. I have 8 electrons in my drawing total. 1, 2 in the bond, 3, 4 in the other bond, 5, 6, 7, 8 is dots. Does that equal step 1 what I added up? 8. It does. I have 8 in the picture and 8 electrons is what I added up. So the check worked out. Single bonds worked. There's no double bonds in water. All right, great. Let's look at one more before I send you off to look at some other examples. CH2O with the C underlined. Let's add up the valence electrons. Carbon is in column 4. So 4 valence electrons. Hydrogen is column 1. So 1 valence electron, and there's 2 of them, so 1 times 2. Oxygen, again, is in column 6. So 6 valence electrons. So 4 plus 2 plus 6 is 12. Carbon's the center atom. Put it in the center. Draw a single bond to an O. Draw a single bond to an H. Draw another single bond to an H. That's how we start. Now let's make everybody happy. Okay, the hydrogens are already happy because they have single bonds, which means 2 electrons, so the hydrogens need 2, so they're done. Now the carbon in the center has 1, 2, 3 bonds around it. Remember, carbon's in the center with 1, 2, 3 bonds. So that's 6 electrons. So it needs 2 dots, a lone pair. Draw the dots together. Oxygen up here had 1 bond, so that's 2. So it needs 3, 4, 5, 6, 7, 8. 3 lone pairs around it. Now, let's see if that's 12 electrons. So 2 with the hydrogen plus 2 with the hydrogen is 4. The 2 dots, 5, 6. The bond to the O, 7, 8. 9, 10, 11, 12, 13, 14. That didn't work. That's not 12. So that's what I mean. If single bonds don't work, you need to double. Now, can we double bond to a hydrogen? No, because hydrogens can only have 2 electrons around them, and that's 1 single bond. So if we can't double to the hydrogens, we double to the oxygen. We double bond to the oxygen. So erase all your dots if you were drawing this out. Erase your dots. We have a single bond, double bond to the oxygen. Now make everybody happy again. Carbon's in the middle with a single, and double bond. That's 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. It's good. Carbon's good. No dots on the carbon. Oxygen up here has a double bond. That's 1, 2, 3, 4 electrons. So it needs 5, 6, 7, 8. 4 dots. Looks like this. Yeah, let's see if that's 12 electrons. Look at the picture and count. 1, 2 in the bond to CH. 3, 4 in the bond, the other bond to CH. In the double bond, there's 5, 6, 7, 8. And then the dots, 9, 10, 11, 12. So we do have 12 electrons in this picture. It worked. All right, at this point, you're going to watch some videos where I'm writing on paper and explaining some Lewis dot structures for you. So good luck with those. Catch you later, GCC.